I'd like to introduce Gary Shigenaka. He is a retired, and I think I can say happily retired biologist with NOAA, also boots on the ground after this bill, and has led a distinguished career. And I'm really excited to have him here with us tonight to share some of the history and some of his thoughts looking forward on spill response. So, Gary, the floor is yours.
Thank you very much, Danielle, and thank you for working with me to get ready for the talk, all the prep. Thank you, Donna, for not vetoing the choice for me to come and speak to you tonight. Um, so when Danielle asked me for a title for this, I gave her a very vague title, and it's reflected. Oops. It's not reflected here, but as Jeff alluded to, the Exxon Valdez spill was a long time ago. So those of us who had firsthand experience with the spill are by definition old. So this is my very vague title for the talk, a look back and some thoughts about the path ahead. And one of the reasons that I gave a very vague title is that it gives me a lot of leeway to wander all over the place because I've thought about this spill and its after effects and its effect on my personal life for a long, long time. So you're going to get a little bit of all of that woven into the fabric of this discussion tonight. Like Jeff, my career in spill response has been bookended by the Exxon Valdez and the Deepwater Horizon, and I'll talk about both of those incidents in my talk. My focus after a long career with NOAA is different from Jeff's. Jeff was on the hard research side. I worked to support spill response for the Coast Guard and other agencies over many decades. But certainly these two incidents were the defining portions of my career. So this is the outline of what I hope to cover tonight. We'll just go over some of the same stuff that Jeff talked about, reviewing the incident itself, some of the science. I'm going to talk a little bit about some of the science we did in my group, looking at the effects of the cleanup. Jeff talked to you about some of the more focused studies looking at effects and impacts from the spill. Some of you may know that I have this interest in oil spill history, so I like trying to include a little bit of oil spill history in all the talks that I give, so you're going to be subjected to that. And then one of the, I think, very interesting and very promising developments that's occurred since the Exxon Valdez is the integration of community considerations, both community impacts and community involvement in science and in other projects in the potentially affected areas in the Sound and across Alaska. And then a little bit of speculation about what's going to happen in the future. And, who really knows, but you're going to get my take on that. So Jeff talked to you about the science. Here is some of the science. And he also talked to you about how the science that he worked on during Exxon Valdez has really led to many other confirming studies from the Deepwater Horizon. A lot of these studies have to do with the effects on developing fish, and they're really groundbreaking and they're very important, and they give us a real window into understanding the effects of oil on the ecosystem. And it's a big paradigm change that we'll discuss in a bit. I wasn't sure what Bex was going to talk about with Isaac, but I speculated that it would have something to do with community involvement. And indeed, her and Isaac's talk really underscored the robust and mature state of both community science and community projects to protect and understand the environment that a lot of the native communities inhabit, and how to deal with that moving forward into the future. I was just going to mention that if you go from left to right in this slide, one of the early attempts to try to understand how do you communicate science to a lay community, and in this case, for the Exxon Valdez, it was trying to communicate some of the effect studies related to seafood safety, and it's really evolved in terms of the communication piece. It's evolved from a top-down kind of, well, the scientists will come in, they'll tell the community what they're doing, and then they'll leave. But on the far side of this slide, on the right-hand side, you see that it's become much more of a community-driven effort to do science and to do the things that the communities feel are important. And I think that that's a really positive aspect of what's come out of Exxon Valdez and other oil spills. So we've seen many pictures like this, the spill itself and the cleanup. And again, the cleanup side of things is what I was involved with for a long time. Just more of the same facts that Jeff flashed up there. I think you all know about this. Good Friday, transporting oil from the Valdez terminal to Long Beach, California, and the vessel made some course corrections to avoid ice coming out of Valdez and ran into Bly Reef. And so about 11 million gallons spilled from this, and it resulted in the largest maritime spill in U.S. history to that point. So in terms of what caused the spill, this is from the National Transportation Safety Board report on the Exxon Valdez spill. And you can see I highlighted a lot of the words failed. In this case, there was plenty of failure to go around, from the vessel itself to the corporate offices of Exxon to the governmental oversight people in the Coast Guard, to the escort services in Valdez. So just really across the board failure led to this particular incident. And I always have to show this type of slide. Dave Janka's in the back, and it's like every Christmas you get letters from people showing what's gone on with their family in the past year. Dave would always send out pictures of mostly Eleanor Island, Northwest Bay, showing residual oil in the environment. And this is the latest one that I could pry out of Dave from last year, not this year. But the point is that there's still residual oil in the environment, and that's something that we, on the response side, did not expect when the Exxon Valdez took place. So those of you who do know me and have listened to me blather on in other venues know that I've been talking a lot about the history of oil spills. It's become really a very popular topic, and there isn't a whole lot of information out there about the history of oil spills. So I spent the last probably 5 to 10 years of my NOAA career diving into this history, and so I've tried to include some of it in many of the talks that I give. And I'm also incorporating AI, so I got to keep up with the times. Now about AI, when I gave the history of oil spills talk in 2024, I decided, well, I'm going to ask ChatGPT what the first oil spill was, because that's one of the things that I talk about in my history of oil spills talk. So I asked ChatGPT, what was the first oil spill? And it gave me an answer that astonished me. I'd never even dreamt of this particular answer. And it told me that the USS Monitor, which those of you who have any history background know was the ironclad ship in the Union Navy that was sunk off the coast of North Carolina during the Civil War. And ChatGPT told me that the monitor was the first recorded oil spill. And I thought, holy smokes. It said that it released its cargo of 90 tons of coal-derived oil. So I decided to check on this. And I went to the source. I went to the National Marine Sanctuary, the Monitor National Marine Sanctuary in North Carolina, and asked the archaeologist. And you can't read the letter that I got back, but this is what the archaeologist told me. He said, no, that's not correct. He said, we have unearthed no reference to oil's use in powering the engines or boilers, and there's no oil at the site. And he just speculated that maybe people or ChatGPT confused some of the World War II wrecks off the coast with the Monitor for being a source of oil. So what I would tell you in going to ChatGPT is trust but verify. Back in the 80s, Reagan would always say this phrase, doverya no proverya, which is Russian for trust but verify. And he would say this at every meeting he had with Mikhail Gorbachev, and it really pissed the hell out of Gorbachev. He would say to Reagan, you say that at every meeting. The other night, when I was doom scrolling because I couldn't sleep, I happened to come across this particular article in the middle there, hallucination rates, which is, I think, a very novel way to call error rates of AI models. And I was really surprised to find that you can see on the right-hand side that the error rate for AI models is surprisingly big. And it's really big for Elon Musk's Grok 2 and Grok 3. I just want to note 94% for Grok 3 and 77% for Grok 2. Okay, so this brings us back to the Exxon Valdez. I did ask in prepping for this talk, ChatGPT, what's the legacy of the Exxon Valdez spill? And this is what it spit out. And of course, probably the people in the front row can't even read this. So I tried to summarize it a little bit. And to be honest, it's not bad. It goes through a whole series of considerations that it's calling the legacy of the Exxon Valdez. And I'll read some of those off for you because I know you can't see them. There's environmental damage, there's legal and financial accountability, policy and regulation changes, scientific research and understanding, cultural and societal impact. And it concludes, overall, the Exxon Valdez oil spill created lasting changes that shaped environmental policies, corporate accountability, and public perceptions of oil drilling and environmental stewardship, which ain't bad. You know, that's pretty good. That's a pretty decent accounting of the legacy of this particular spill. Jeff showed this slide. We know about the damages to the resources in Prince William Sound and outside of Prince William Sound. And we know that there was kind of a gradient, a timeline of when those resources recovered. So some things, like the intertidal environment, the shoreline, recovered quite quickly, relatively speaking, a couple of years. Other things have not yet recovered, and some things we just don't know about. Jeff gave you the background for the salmon studies, and you see a couple pictures of Jeep Rice, who oversaw many of those studies at Auk Bay for many years. The shot on the left-hand side in the middle there is Jeep as a young man, and on the right side as he approached his retirement. But the point is there was a major shift in the oil toxicity paradigm. As Jeff indicated, that instead of looking at acute toxicity, the killing outright of exposed organisms at parts per million levels, the initial studies indicated that developing fish were much more sensitive at the parts per billion level. That's 1,000 times more sensitive. And it really changed the way we think about oil toxicity. This is a very complicated graphic that was put out by the trustees after the Deepwater Horizon spill, but the takeaway is that there were a number of commonalities as those damage assessment studies took place after the Deepwater Horizon. Many things showed up in different levels of organization in different organisms. So as you move out from the center there where the oil is out to the outer rings, you're going from cellular and subcellular level impacts all the way out to organism effects, and then beyond that would be community effects. So we're a lot smarter now than we were even before the Deepwater Horizon and after the Exxon Valdez. So Jeff talked to you about all of that stuff. I'm going to talk to you a little bit about some of the things we did on the response side. We supported the Coast Guard with scientific support during the spill, and just some shots here of the cleanup, which was massive and industrial scale. When we first started thinking about potential impacts of the cleanup to the exposed organisms, some of us began to think about this particular spill from 1967. It's the first large oil spill, the first supertanker spill. It occurred off the southern coast of England, called the Torrey Canyon, 1967. There's a group of islands off the southern coast of England called the Scilly Isles, and they're notorious for wrecking ships for the last several hundred years. And that's where the Torrey Canyon ran aground, spilled its load of oil. There were many attempts to salvage, and then they called in the Royal Navy to bomb the wreck to try to burn it off, and none of it was successful. On the response side, this spill was famous or infamous because very toxic chemicals were used both on the water and on the shoreline. Back in those days, we had a very different conception of toxicity of some of the things that we would do on the shoreline. Very different, you can see here. So what they're doing is they're applying, you can call it a dispersant or a shoreline cleaner. A lot of these early formulation shoreline cleaners were based on petroleum, like kerosene. So anybody should know that that's going to be pretty toxic, and it was. There were some studies that took place by the Marine Biological Lab in England during and after the Torrey Canyon spill, and you can see some before and after pictures of the intertidal, some limpets that were exposed to the chemical that I think maybe the next day, a couple days later, were simply gone, and you could just see their ghostly outlines on the rocks. Some effects that we observed during the Exxon Valdez spill. On the left-hand side, you see a normal rocky shoreline. After everything on that rocky shoreline was killed off, then a very weedy green algal species came back in, and that's a typical kind of early response to everything being cleaned off of a surface in the rocky intertidal. So these are some shots from Northwest Bay, 1989 on the left-hand side and 2008 on the right-hand side. This particular site was washed with high-pressure hot water. You can see it basically killed off all of that rockweed or fucus. By 2008, it grew back. And what we found in our response studies was that, yeah, there was a bigger hill to climb for recovery on those sites that were cleaned with high pressure hot water. But after 2 or 3 years, they kind of equalized between the oiled sites and the sites that were aggressively cleaned. So it took a couple of extra years to reach that equilibrium. This is kind of an idealized view of what recovery might look like. You see on the left-hand side of the graph, normal variability in some system, and it doesn't really matter what you're measuring. It could be algal cover, it could be the number of limpets or snails. And then you have an oil spill, causes all of that to drop off, and then slowly that recovery period climbs back up over time, and eventually you reach that same level of variability. What some of our studies, or what our studies showed, was that we didn't really know what conditions were at many of the comparison sites that we were looking at to compare to oiled and treated sites. And so it could be, and we wound up assuming, that the conditions at our control sites, baseline sites, were different to begin with. And so we defined recovery a little differently than is traditionally the case. And let's see. Ooh. Well, I'm going to step away here. It's just when the patterns begin to mirror each other again, and we call that parallelism. Not everybody bought into it, but it's one way to define recovery after an event like the Exxon Valdez. Now, in the Torrey Canyon spill, the researchers who were looking at the effects, comparing oiled sites and clean sites, found similar sorts of things. They found that sites that were oiled only recovered after only 2 years, whereas the sites that were basically sterilized with those chemicals took as long as 15 years. So the guy who's been following up on this stuff is a man by the name of Stephen Hawkins, not to be confused with Stephen Hawkins, the physicist, but he pointed out in the bottom paragraph there that you have to take into account larger scale changes that are going on in the environment, things like climate change driven things, BECS, climate change, that may be affecting conditions at a site when you try to ascertain the impact of an oil spill. So that complicates things, and it gets more complicated the more we get into changes imposed on the global climate by things like warming and other changes, acidification. Oh, this is just a table from Hawkins' paper. It just compared recovery, and I know you can't read this, but I will summarize it for you. Recovery from different spills varied from 2 years to 5 years. For those sites that looked at aggressive cleanup, longer than that, 10 to 15 years. So there is some consistency across different spills in terms of looking at the effects of what we're trying to do to mediate the impact of the oil itself. The other thing, this was kind of the last thing that I studied and presented on just at the Alaska Marine Science Symposium in January, but we thought there might be some collateral impacts from the aggressive washing. You can see that there's a lot of silt in the water being washed out of that beach, and you could see that from aerial photographs as well. So we hypothesized that you needed to have the physical environment return to some normality before the biology could come back in. Because, you know, those critters can sometimes be pretty picky about the conditions that they need to settle back in. So we decided we would do an experiment out in Lower Herring Bay in Prince William Sound. And we started this in 2000 and ran it through 2012. And so we did our own aggressive cleanup with not with oil, obviously, but we washed out all of the fines from study plots and then replaced the remaining material back into the plots. And then we tracked what happened for 12 years. This is the glamorous part of science. You can see it's also very Alaskan, you know, doing field work in head nets and oilskins. So this was our working hypothesis, that recovery of the physical habitat as defined by grain size structure of the plots would be a necessary precursor to the recovery of the biological community. It turns out we were wrong. And what we found was that actually the critters came back pretty quickly, like within 1 to 2 years. And it took almost 10 years for the grain size structure in those beaches to come back. So go figure. We could speculate, or I have speculated, that it has to do with the fact that a lot of those communities have a pretty rough life to begin with. You know, they live in a pretty harsh environment. They have to deal with constantly changing conditions. So their reproductive strategies and their survival strategies make them pretty adept at coming back in and grabbing some real estate whenever they can. Okay, and I can't give a talk without crediting my colleague, my old colleague, Alan Mearns, with Mearns Rock. Many of you have seen pictures of this. We thought Alan was crazy when he started this in 1990. We would be out monitoring our study site in Snug Harbor. Alan would be videotaping and taking pictures of a boulder. And as it turns out, he is way smarter than many of us, because what this photo portrait series has shown over all this time, all the way through 2025, is that the environment is inherently variable. It changes incredibly from year to year. Do we know why? I don't think so. We can begin to speculate that it has something to do with water temperature. It might have to do with ice scouring. It might have to do with a lot of things. But the point is that it's an incredibly robust and variable environment out there. We can connect this to another study from even earlier, and I bet none of you have heard of this one. Tampico Maru, which occurred in 1957. It was an oil tanker that was sold for scrap to Japan. And some brilliant person said, well, we're sending it over to Japan anyways. Let's load it up with oil and we can sell the oil too. So they got as far as, I believe, Ensenada, Mexico. When they hit some weather, the ship's welds began buckling, coming apart, and then the tow line broke. So it grounded in this little cove in northern Mexico. And it turns out that this emeritus professor from California Institute of Technology, Dr. Wheeler North, started monitoring it. And he monitored it for, 27 years, from 1957 to 1984. So one of the longest term oil spill monitoring programs in existence that nobody knows about. And Wheeler observed many of the same kinds of things that we've been talking about earlier, that you know, the oil impacts did go away, and he said that there was no oil that he could see within 2 to 3 months, and that after 3 years things seemed to be pretty much back to normal. But I highlighted in yellow the fact that he recognized back at that time that conditions at the sites that they were looking at, comparing, may have changed. The baseline conditions may have changed in the years that they were monitoring. So you wouldn't necessarily expect the conditions to come back to 1957 levels. And that's been the point of what we found too in Prince William Sound. So just to summarize, Tampico Maru, Torrey Canyon, and then Exxon Valdez, we sort of see the same kinds of conclusions, that there's this variable baseline that we have to take into consideration, and that baseline that we're comparing oil impacts to may be affected by climate change and other smaller scale events that are going on all the time. Okay, so we're shifting gears. Now, community impacts. This is sort of a famous choice of words by Don Cornett, who was the Alaska coordinator for Exxon, who stated when he was talking to some fishermen, we will consider whatever it takes to keep you whole. And people remembered those words. Fishermen remembered those words. And this guy in Cordova, Mike Weber, created this shame poll that is highlighted by those words. So community impacts really came to the fore during Exxon Valdez. I took this shot in Cordova at the Reluctant Fisherman, which I was happy to learn is still in existence there in Cordova. If you can't read it, it says flags are at half-mast due to the death of our environment. So a recent study, fairly recent, 2016, by a researcher by the name of Dwayne Gill, looked at the long-term community impacts from Exxon Valdez. And he concluded, again using Don Cornett's words, they have not been made whole. So that's what, 24 years after the spill that he concluded that. And I don't often agree with many things that Governor Palin said, but you can't argue with this. She said in 2008, deterrence here is the operative word. We do not want this to ever happen again to any other community, state, individual. Can't argue with that, right? So we saw this earlier looking at the biological effects of the Deepwater Horizon spill and the kind of cascade of impacts going out from very microscopic levels out to organismal and community levels. And it turns out that people have done this same sort of thing with human impacts, sociological, psychological impacts, going from individuals out to the community. So there's a much greater understanding that these transient disasters that we experience, whether they're oil spills or maybe hurricanes or more recently, catastrophic floods in northern Alaska, people are affected, and this cascades out to the very fabric of communities. Kind of linked to all of this is the notion that oil has been linked to legislation over a very long time. I have a quote up here from 1917 talking about the pollution of waters off of California that's affecting birds. And people have observed this for a very long time. In this case, the oil was coming from oily bilge water, just being dumped haphazardly into coastal waters. And on the East Coast, the same sort of thing was occurring. People were looking at not only the effects of bilge water, but also just the rampant dumping of oily waste into streams and rivers along the East Coast. So very early on, this resulted in the Oil Pollution Act. And you may say, what? 1990, right? But there was an Oil Pollution Act in 1924, and it came about largely because of these impacts that were being seen on both coasts, the West Coast and the East Coast. And again, the Oil Pollution Act of 1924 was focused on mostly oily bilge water, but it was a beginning. And so these other oil spills that occurred well after 1924, like the Torrey Canyon, also inspired a number of legal and regulatory changes. The Torrey Canyon prompted a whole bunch of international changes to the governing environment, international maritime regulations, and then it sort of laid the groundwork for the changes to come to the U.S. Oil spill response preparation and response network. Similarly, the Union Oil platform blowout 2 years later, in 1969, got a tremendous amount of press play. This is one of the first times that there was widespread coverage of oily birds, oily mammals, oily surfers. It really kind of is the beginning of the American environmental movement. And believe it or not, all of these laws that you see here were implemented during President Nixon's reign. And these are landmark pieces of legislation that have mostly survived to this day and really are the foundation of how we protect and guard the environment. I think many, if not most of you, know the result of the Exxon Valdez spill. It really institutionalized the way we respond to oil spills, required a lot of contingency planning, enhanced the Coast Guard response capabilities, the Oil Spill Liability Trust Fund that pays for a lot of cleanup when there's no viable responsible party, natural resource damage assessment, phased out single-hulled tankers, and created the regional citizens advisory councils in Prince William Sound and Cook Inlet, and notably banned tankers that have spilled more than 1 million gallons of oil into the marine environment after March 22nd, 1989, from entering Prince William Sound, which was challenged in court but upheld. So you may think, like many of us did in 2010, well, there's some big changes coming to US legislation after the Deepwater Horizon. So here's the list of those major changes. I'm glad the sound works. Okay, so that brings us to the present. Where are we now? Now, if you're like me and you can't help but look at the news, it seems like it's all bad news. It's all, especially when it comes to the environment, it all seems really gloomy, terrible. So what kind of sense do we make of all of this? Well, you may see some familiar faces in this slide. A promising development was the National Academy of Sciences, Engineering, and Medicine workshops that were held here in Anchorage and in Thibodaux, Louisiana, and in Washington, D.C., to focus less on science and more on community impacts from oil spills. And it asked a series of questions. And these involve science and oil spill impacts, but they're kind of flipped back and looking at, well, what are the effects on communities? Whether it's from fisheries shutdowns to how do we implement better community-oriented research to look at human impacts. So that's a big change, and I think it's very promising as we move forward into the future. I think it's an amazing thing that the regional citizens advisory councils have been so robust and such a presence in both Cook Inlet and Prince William Sound. And I think that's a wonderful model. It's really too bad. It's something that can't be sort of ported out to communities all over the country. And I suspect that when Donna and other folks from the RCAC go out and do presentations in the lower 48, people are always asking, well, how do we do that? How do we get that? This is going to be hard because it's in the legislation. Remember, if we go back to OPA 90, it's in the legislation, and the chances of that sort of thing happening again, I think, are pretty small. In my neck of the woods, we have this other community-based organization called IOSA, the Islands Oil Spill Association. And this is a community-based response group that does small level responses in the San Juan Islands of Washington State. And as many of you know, that's a fairly remote part of the state near the Canadian border. And it takes time for the Coast Guard and the state to respond to incidents that may occur there. So IOSA provides early eyes, and it provides a modest level of response capability to respond to spills in that area. And it only has become a robust entity through the support of, you can see up there in the center, upper center, through the support of the state of Washington and San Juan County. The refineries in the northern Puget Sound area also chip in funding support. So again, it would be a great model for other parts of the country, but you have to get buy-in from industry and from local government in order to do this. And it seems a little unlikely in this kind of a funding climate that we'll see that, but it's a template, just like the RCAC is. So, as you know, I come from NOAA, and I wanted to point out the loss of capacity that's occurred in the past year with not just my old group, which was the Emergency Response Division, but also larger NOAA. You've probably heard about the impacts to the Weather Service, and didn't they just take down the seismic network that was operative here in Alaska? For the Emergency Response Division, beginning in early 2025, we lost 43% of the capacity of the personnel that we had on board, which is it's really big. That's a big hit with many, many years of experience. The Emergency Response Division resides within a larger organization called the Office of Response and Restoration, which includes the damage assessment people. That loss of capacity was 33%. And then this is sort of astonishing. For larger NOAA and the Weather Service, 27,000 years of experience was lost in the early retirements and the forced retirements that occurred earlier this year. So this isn't just affecting NOAA, it's affecting all of the federal agencies that operate up here. So I need to recognize that and lament with my federal employees and retirees. This was an editorial that just appeared in the Seattle Times this past week. It says, the pipeline that nurtures the next generation of young scientists is at risk. And I think this has the potential to be the largest, most devastating impact for the future. And that is that young people who are in college, maybe just in high school or middle school, will look at what's happened to the federal science community and say, boy, I'm not going to follow that path, because who knows, there's no job security. It seems like a pretty precarious way to practice what I want to do. So I think that has the potential to be a really devastating impact. Further looking at the future, I just wanted to mention that every time there's a spill of any size, people always say, you really haven't improved the response techniques that you've used for the last 36 years. And if you look at these pictures, the top is Exxon Valdez, the bottom is Deepwater Horizon. They look pretty darn similar. And part of that is due to the fact that you're battling the laws of physics. You're dealing with oil spreading out on a surface, and it's just a lot of surface to try to address. So you're battling physics, but there are some promising developments. There are new technologies that are coming online. Towards the end of my career and in current days, we've become more reliant on our satellite partners to give us a heads up that something looks funny out there on the water. So the satellite people have gotten a lot better at discerning oil in the environment, and they alert my old group, the Emergency Response Division, when they see something that looks funky. So that's promising. And people like Scott Bacow, who's in the back there, helped spearhead a lot of great research trying to push the envelope on how to respond to spills in the Arctic environment. So I'm really hoping that that continues into the future. And there are other technologies like drones, both on the water and in the air, that will help to make us more effective and more efficient. This is pretty old school, but I think it's pretty cool. And Scott and I went out and observed this, looking for old oil in Prince William Sound. And this is the use of canines to detect oil, not only on the shoreline. Just a couple of weeks ago, I talked to a group at Texas Tech that is interested in trying to look at dogs as a way to detect contamination in seafood. So if you've seen how it's done now, there's this kind of wonky looking series of humans who sniff and taste seafood to see if it's contaminated. That's used as a screening tool before it's subjected to chemical analysis. But if you think about dogs, dogs have noses that are a lot more sensitive, and they're unbiased, right? So I think there's some promise in kind of this old school, old dog technology. And just a little bit on communication. We've gotten a little better, I think, or at least a little more cognizant of the fact that we need to do a better job of communicating oil spill science to affected communities and lay people who don't really have a science background. So NOAA has always put out these what we call one-pagers, like on the left-hand side, to try to explain to people what we're doing with oil spill science. But during the Deepwater Horizon, we realized there's a big community out there that is non-English speaking. So we had to take these one-pagers and translate them into, this case, Vietnamese. So there's a much greater realization that community impacts are important. We need to figure out a better way to communicate with those affected communities. Oh, and then this is just a shot from the science symposium. 30 some odd years ago, we gathered at the Captain Cook to talk about oil spill science from the Exxon Valdez, and that morphed into the Alaska Marine Science Symposium, which I think is a wonderful benefit to the community because there's almost I was the only oil spill related paper, I think, in this year's symposium. All the other papers were on much more interesting things and a much broader palette of the science that goes on in Alaska. And I think that same sort of thing beginning to take place in the Gulf of Mexico. There was a series of oil spill conferences that took place, and hopefully they continue in the Gulf region. This as a way to communicate science in that region to the lay community and any other interested folks and scientists themselves. Oh, I was going to talk about social media. I don't have a lot to say other than it's kind of it's kind of an unknown out there with the effects of social media. This is a graphic from an early analysis of the Twitter clicks during Deepwater Horizon. And up in the upper right-hand corner in red are the sort of non-affiliated, non-governmental, non-profit groups that loomed large as sources of information for people. So I think the next time there's a big incident, we're going to have to deal with social media. How do we communicate effectively or at all with a vast audience that doesn't really want to hear something from the government or from other cleanup related people. So that's a big unknown for me. I don't know what's going to happen in the next spill. Okay, so I'm going to wind up on this. This is from my looks at historical incidents, beginning from the very first large incident that I've identified in 1903 in Australia from a ship called the Petriana, continuing all the way through the present day, almost all of the post-incident analyses have pointed out some involvement in human error, negligence, mistakenly passed inside the lighthouse, imprudent, negligent, inadequate safety precautions. Exxon Valdez, we talked about that, but there were a lot of failures there, a lot of the failure word there. Deepwater Horizon, there was a cascade of errors that took place, mostly related to human judgment and oversight. And then all the way up until the last incident that I have on this list is from a report that just came out, I think last week, from the Olympic pipeline spill down my way in northern Washington. Now, some of you may have heard and were affected by the Olympic pipeline spill that just occurred like a few weeks ago. And this is the same pipeline, but this analysis from the state of Washington is from a previous pipeline break in the Olympic pipeline. And again, it was failure. There was a spill in California, Huntington Beach. They ignored 83 alarms, didn't shut down the pipeline. So there is this common theme of human failure. The other thing that is sort of scary is that there's this. This is a quote from the Challenger, Columbia shuttle accident, and one of the conclusions was that complex systems almost always fail in complex ways. So those of you who were putting all of your eggs in a technology basket, I say, too bad, it's not going to work. Because we see every day in the news reports of technological failures, things that people have invested a lot of time and a lot of brain power in designing and implementing, and in this case, launching, and there have been a lot of failures. So I'm going to wind up on this. This is pretty much my most boring slide, and I saved it for the last, but in the industry, there's this concept called operational integrity. And what it basically means is that for you to reach a goal in some project, you need three components that are working. There's people, systems, and equipment. And on the right-hand side, you see that Venn diagram. The intersection is what you have to have for success. And in the case of oil spills, there's always been some one of those three circles has not been working right. So that's something to keep in mind, even if it is a boring concept. And I also wanted to point out Dan Lawn. Do you folks know who Dan Lawn? Okay, all right. Famous icon. He began pointing out inadequacies in Alyeska oversight and other problems with the response system in Prince William Sound as far back as 1984. And he was lucky enough to be portrayed in the movie by John Hurd. So in 2008, I interviewed Dan, and he cautioned at the end of the interview that he saw us returning to this sense of complacency in the way that we thought about oil spills. And what happened 2 years later? It was the Deepwater Horizon. So he's kind of a soothsayer that has lasted through the years. You know, is Dan still around? No. That explains why he didn't answer my email. I wanted to update some thoughts from him, and I couldn't find any report of his demise. So I did send him an email, but now I know why. So this is what we talked about. You know, hopefully we touched on all of these things. I did want to end on, ChatGPT again. I asked just in the last couple of days, what does the future hold for oil spill preparation and response? And once again, ChatGPT was very chatty. Um, and I tried to distill this down a little bit. And once again, it was pretty good. So you can do this at home. You can ask ChatGPT. You have to take it with a grain of salt. Remember, dovere no provere, trust but verify. But I think maybe it's getting a little better on some of these bigger questions. Just don't ask it about the first oil spill or something like that. The other thing that ChatGPT is really good at is writing songs. And so I've been doing this a lot. I've asked it to write songs about oil spills. And you can specify style.
The water's skin turns slick and black. No moon can dance, no stars look back. Feathered wings sink stained with grief. Life once strong now comes to brief. The
Gotta
otter
admit, that's not bad for a computer, right?
the wave, it fights.
Okay, I don't know. Is there time to just blast through this? Some of you may not know what happened to the Exxon Valdez, the ship itself. So I always like to go through this. Built in 1986 and met its demise in 2012, but it went through a lot of different iterations. And we won't go through them all, but Exxon tried renaming it and then sold it and then got turned into a cargo ship. Had some other incidents in the South China Sea where it ran into other vessels. And it was finally taken to India. You know, there are those shipwrecking yards on the beaches of India, and that's where it finally died in 2012. And this is the last known picture of the Oriental Nicety, which was its final incarnation before it was dismantled. The Smithsonian tried to get some of the bridge equipment from the ship, but they were too late. It had been already taken off the ship, which is really too bad. But there you go. There's the end of the Exxon Valdez, and that's the end of my talk. And I may have opportunity for maybe one question.
Thank you, Gary. Are there any questions online or in the room?
Oh, Donna.
Gary, I know you have a large collection of, memorabilia from Exxon Valdez. You were trying to find a home for it. Do you still have that, or have you found a home for that collection?
I do. I didn't have time to show it off, but the 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 big piece, literally big piece, is a life ring, and I showed that picture of me on the Exxon Valdez in 1989. Somebody, not me, pointed out when they looked at the picture of the life ring I currently have, it's the same life ring that I'm posing with in 1989. So I have that. I have a bunch of I don't know, christening glasses, and my cupboard is filled with Exxon Valdez mugs from the shipyard and baseball caps and all sorts of other things. I actually was working with the curator of the maritime collection at the Smithsonian to hand off some of this stuff, but he left in the big purge earlier this year. So I'll have to see who's running the show now. But yeah, it's a little embarrassing that I keep picking this stuff up. I'm supposed to be de-accessing all of my belongings now at my age, but there's
I don't need a microphone. Gary, I just really enjoy your talks. And I was intimately aware of I worked on that Union Alpha platform when they built it. And I know what a disaster that turned into. I grew up in California, Santa Barbara. That's where all offshore oil started. And I was involved in the Exxon Valdez. But you, my friend, have captured it. You are bringing the word. And I think that your talks will instill something to the youth where it's just not the Exxon Valdez, but it's the value of preventing that. So I thank you.
Well, thank you. Those are very kind words. Thank you very much.
We have one question online.
Not a question, but Nancy Bird online said, Gary, what a great presentation. I want your oil history book. Publish it soon. Thank you for a fun retrospective and for so much knowledge, Nancy.
Thank you, Nancy. Okay.